A free beta racked up 5-figure OpenAI charges overnight. The API key was visible in browser dev tools. The article uses server actions with use server directives. In Next.js 16, server actions are stable but require the experimental server actions flag in Next. Config.js if using versions prior to 16.00. Ensure your Next.config.js includes experimental server actions, true for compatibility with older Next.js 16 releases. The article mentions checking token quota before AI calls, but does not show the code. Here is a concrete implementation using Supabase RPC to atomically decrement the user's monthly token allowance, preventing race conditions. The article mentions setting a hard spending cap in the OpenAI dashboard as a safety net. This is critical because rate-limiting code can have bugs. Set the cap to 2x your expected monthly cost during beta and monitor it daily. Additionally, enable email notifications for usage thresholds in the OpenAI dashboard to get early warnings. Let's break down building an AI SaaS from scratch with Next.js 16, how it works, and the exact mistake behind that failure. Building an AI SaaS on Next.js 16 means constructing a full-stack application where the server handles API key management, usage tracking, and billing, not just rendering UI. The core challenge is that your users' OpenAI keys are high-value targets. A single leak can result in a 5-figure invoice. Before writing code, verify you have the required accounts and tools: Node.js 20+, Supabase CLI, Stripe CLI, and accounts for Supabase, Stripe, Upstash, and OpenAI. The stack is deliberate. Next.js 16 for the application layer, Supabase for auth and data, Stripe for metered billing, and Upstash for rate limiting. Run these commands to verify your tools and create the Next.js 16 project. The server-only package is critical. It prevents API keys from being imported in client bundles. Environment variables are validated at startup using a ZOD schema. Missing or malformed variables fail the build, not a customer request at 2 a.m. This pattern prevents the most common category of production deployment failures. This ZOD schema validates every environment variable at module load time. If any required variable is missing or malformed, the build fails immediately. The schema is designed for multi-tenancy from the first migration. Every table has a userid column, and row-level security policies enforce that users access only their own rows. No application-level authorization code is needed for basic data access. This SQL creates the full schema with tables, indexes, RLS policies, and triggers. Note the processed webhook events table for Stripe idempotency and the composite indexes on userid created at DESC for efficient queries. Supabase Auth handles the entire authentication lifecycle. The middleware pattern is critical. It runs on every request, calls getUser, to validate and refresh the session token, and redirects unauthenticated users away from protected routes. This middleware uses getUser to validate the session server-side. Always return Supabase response, not next response next, to carry refreshed session cookies. Rate limiting must exist before any AI call can be made. Without it, a single user or a viral launch can generate an unbounded API bill. Upstash provides serverless RDIs with sliding window rate limiting. This code sets up 2 rate limits, a per-minute limit of 10 requests and a per-day limit of 100 requests. Both use the authenticated user ID as the identifier, preventing IP-based bypass. AI streaming responses require a route handler, not a server action. Server actions cannot return streaming response objects. The route handler enforces the complete request lifecycle: authenticate, parse, rate limit, quota check, call model, record usage, return stream. This file creates AI clients using server-only environment variables. The server-only import ensures this file can never be imported in a client component, preventing key exposure. Stripe metered billing ties AI token consumption to revenue automatically. Each AI response records a meter event in Stripe. At the end of the billing period, Stripe aggregates all events and generates an invoice. This code handles customer creation, checkout sessions, billing portal, and meter event recording. Note the idempotency key on meter events to prevent duplicate charges. Deploy to Vercel with 3 isolated environments. Never share database or billing infrastructure between environments. Set a hard monthly spending cap in the OpenAI dashboard as a final safety net. This CI pipeline runs the build with preview environment variables, catching missing env-vars at build time via ZOD validation. This is the same issue we highlighted at the start. Here's exactly why that happened. The startup server action accepted an API key parameter from the client for flexibility. During a demo, a user inspected the network tab, saw the key in the request payload, and used it to generate $12,000 in OpenAI bills overnight. No rate limiting or usage caps were in place. The OpenAI API key was stored in a client-side environment variable, next public OpenAI API key, causing it to be bundled into the browser and leaked when the app went viral on Hacker News. The fix involved 3 protection layers: per-user daily token limits checked before every AI call, server-side rate limiting via Upstash readies using sliding window, and moving all AI calls to root handlers with the API key stored as a server-only environment variable. Never accept API keys from client input. Always read them from server-only environment variables and validate that no client-side code references them. Always use getUser in middleware and server-side code. getSession returns cached data that may be stale, while getUser validates the token server-side and refreshes it if expired. Stripe retries failed webhooks. Without idempotency, the same event can be processed twice, double charging a customer. Store processed event IDs in a database table and check before processing. Use these commands to diagnose common issues. Check for API key exposure in client chunks, verify Stripe webhook signature verification, and check for missing indexes on userid columns. Let's run through some common interview questions. How would you design multi-tenant AI SaaS without exposing API keys? Use server-only env-vars, root handlers, and RLS to keep keys server-side and isolate tenant data. How to implement rate limiting for AI SaaS without bloated code. Use Upstash readies with sliding window, user ID as identifier, and check before every AI call. Why use root handler instead of server action for streaming? Server actions cannot return readable stream. Root handlers return streaming response objects. And a few frequently asked questions. What is the most common security mistake in AI SaaS? Exposing API keys in client-side code by importing them in client components. How do I prevent unbounded AI costs? Implement rate limiting, per-user token quotas, and set a hard spending cap in the AI provider dashboard. Why use Upstash readies for rate limiting? It provides serverless, sub-millisecond atomic operations that work across Vercel's edge functions without database locks. Let's recap the key takeaways. Use import server-only in every file handling API keys. Streaming AI responses require root handlers. Rate limit by user ID, not IP. Stripe webhooks must be idempotent. Ready to go deeper? Up next, building multi-agent AI systems with Next.js and LangGraph, then getting started with Next.js 16, installation and project structure, then pages and layouts in Next.js, file-based routing explained, and server components versus client components in Next.js 16. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.